Day 4 of Unit 9 is on tangents. And so before I even talk about what a tangent is, I want to review the Pythagorean theorem because to figure out whether a line is tangent to a circle or not, we're going to have to use it. And I know we've been using the Pythagorean theorem a lot lately, and it's probably fresh in your head already, but I just want to make sure before we start today. So the main thing I want you to remember is that when I'm using the Pythagorean theorem, the first thing I have to do is figure out which side the hypotenuse is, because that's going to be C here. That's going to be the one that goes by itself on one side of the equal sign. So if I knew that this side was 10 and I knew that this side was 18 and I wanted to find that side, first thing I have to do before I start plugging numbers in and squaring them, figure out which of these three is the hypotenuse. So the easiest way to think of it is as the side that's across from or that doesn't touch the right angle. Okay, so this side over here, that's 18 units long, that's going to be my hypotenuse because it's the one that doesn't touch the right angle down here. It's always going to be the hypotenuse. So the reason I did one like this to start with is because the most common mistake I see when people try to use the Pythagorean theorem is they automatically assume that whichever side we're looking for, in this case that would be this side down here, is the one that goes by itself, and that's not correct. The hypotenuse goes by itself on one side, even if that's not the side that we're trying to find. So if I plug the numbers in here to the Pythagorean theorem correctly, it would look something like this. 10 squared plus x squared equals 18 squared. And if I square 10, I get 100. X squared stays x squared for now. Now I need to figure out what 18 squared is. 324. If I subtract 100 from both sides, I would be left with x squared equals 224. So I'm going to subtract 100, and then I'm going to take the square root of that, and 14.97. So in this case, x would be 14.97. And when I talk about x, I mean that side there at the bottom of the triangle. All right, so now I want you to do one. Let's say that this side down here is 10, and let's say this side right here is 14. I want you to tell me what x is. So remember, the first thing you have to do is figure out which side is the hypotenuse. So pause the video for a minute, figure out what x is, and then push play again to see what I came up with. Okay, well, the hypotenuse is going to be this one down here. It's going to be the one across from the right angle. So 10 squared is going to go by itself on one side of the equation. 4 squared plus x squared goes on the other side. So I'd have 16 plus x squared equals 100. If I subtract 16 from both sides, I would have x squared equals 84. And then to solve, or to finish solving it, I would just need to take the square root of both sides. And it would be about 19.17 if I round. Sorry, 9.17. So this side up here would be about 9.17 units. Well, other thing we need to review is that all radii in the same circle are congruent. And so what I can see on this circle here is that this radius right here from J to L is 8 units long. That means that any radius I draw inside of this circle, in other words, any straight line from the center out to the edge of the circle would be 8. I could draw infinite radii within this circle. Every single one of them would be 8 units long. The way we're going to use that today, and if you get a problem like this on the test, is because if I want to determine whether this line KL is tangent to the circle, I'm going to have to use the Pythagorean theorem, meaning I'm going to need to know all three sides of this triangle. And right now, I don't know I don't know the length of KJ because I know that from here to here is 9, but I don't know what that part of it is. Well, actually I do, because J to here is just a radius of that circle, so that part would be 8. And then to get the length of the hypotenuse, I would just have to add those two together. 9 plus 8 is 17. So I could set up my problem like this. I would know the hypotenuse was 17, I would know that side was 8, and I would know the side down here would be 15. Okay, and we'll see why we want to know all three sides here in a minute. For now, I just want to remind you that all radii within the same circle are congruent. See if you can figure out what this red line would be equal to. So pause the video for a second, write down what you think that segment is equal to or how long that segment is, and then restart the video to see if you were right. Well, hopefully you got it, because the radius in this circle is 6, and f to this point is just a radius, so it would also be 6. And so if I was going to draw this triangle, this side is 8, that side is 6. The hypotenuse is going to be 12 plus 6, which is 18. Okay, new materials. Finally, I'm going to talk about what a tangent line actually is. It's just a line that intersects a circle in exactly one point and is perpendicular to the radius of the circle from the point of intersection to the center of the circle. Okay, that's a lot of words. Now I'm going to draw a picture of one so you can see more what it looks like. If I have a line that starts somewhere outside of the circle and it touches the circle in exactly one point, and I know that my line there kind of intersects with the circle at more than one point, but let's say it only intersects right there. If I was being more precise, if it only intersects right there, for that to truly be a tangent, it would have to be perpendicular to a radius drawn from the center of the circle to that point. In other words, this right here would have to be a right angle. If the intersection between this radius and this tangent line is indeed 90 degrees, then that would be a tangent. If, on the other hand, I drew a line like this, and I said that the point of intersection was right here, and let's say then I drew a radius to that point, and let's say I measured it and it turned out that this angle was only 88 degrees. Well, then that would mean that that was not truly tangent to the circle. Okay, so for a line to be tangent, it has to intersect with the radius to that point at an exactly 90-degree angle. So let's say I have a point out here, A, and I have a center of the circle, and I haven't labeled it yet, but let's just call the center of the circle Z for right now. Let's say I draw in the radii from Z to C and from Z to B. And let's say after doing so, I'm able to determine that those radii and those tangent lines intersect at right angles. Well, then that tells me that AC and AB are both tangents to circle Z. If two lines starting from the same point, in this case A, so two line segments starting from the same point are tangent to the same circle, those two segments have to be congruent. In other words, if I know that AC is tangent to circle Z and AB is tangent to circle Z, and both of those lines start from the same point, then I know that the length of AC is congruent to the length of AB. So for example, if I knew that AC was 10, AB would have to be 10. Or if I knew that AC was 2x and I knew that AB was 3x plus 4, I could figure out what x was by just setting that equal to that. I would say 3x plus 4 equals 2x. Subtract 2x from both sides would give me x plus 4 equals 0. Subtract 4 from both sides, x would be equal to negative 4 in this case. All right. Examples of how to actually do problems with tangents. Well, remember what I said before when I first talked about what a tangent even is? I said that in this case, the only line here that could possibly be a tangent would be GF, right? Because it starts outside of the circle and it looks like it possibly intersects the circle at this point G right here. For GF to be a tangent of circle E, this has to be a right angle. So the reason we have this other line drawn here is because the way we can test to see if this is a right angle is to plug these three side lengths into the Pythagorean theorem. If this is a right triangle, so I'm just going to write it out, if triangle EGF is a right triangle, then the three side lengths have to work in the Pythagorean theorem. Then a squared plus b squared will equal c squared. Okay? So what's a, b, and c in this triangle? Well, the hypotenuse is c, so it's telling me here that from e to f is 12. So c is going to be 12, and then a and b are 6 and 10. So I'm going to say 6 squared plus 10 squared equals 12 squared. So I don't know if that's true yet. I'm going to test and see if it's true. 6 squared is 36, 10 squared is 100, 12 squared is 144, I'm pretty sure. So is 36 plus 100 equal to 144? Well, no, it's not. So since that is not equal, then no, line segment GF is not tangent to circle E. So since I couldn't plug these numbers into the Pythagorean theorem and have it work, that means that this line segment here, GF, is not actually tangent to the circle. Same thing over here on number 3. Except now I only have part of the hypotenuse, right? This just tells me that from here to here is 24. This part right here, I don't know right at the beginning, but it does tell me what the radius is, and it's 15, so I just need to put a 15 right here, because from E to this point is another radius in the circle. So if I want to redraw the triangle, I know that this side is 15, I know this side on the bottom is 36. The hypotenuse, right, because here would be my right angle, so this side over here is 24 plus 15, so this would be 39 units long. Okay, so all I did to get that 39 was I said, well, this part's 24, this part's 15. If I add those two together, it's going to give me the length of this whole line, and 24 plus 15 is 39. So I'm going to do the same thing I did last time. I'm going to plug these three side lengths into the Pythagorean theorem. If it works, if I get an equation at the end, then this line segment, FG, is tangent to the circle. If what happens over here is the same as what happened over here, where I end up with something that's not equal, then it's not. So I would have 15 squared plus 36 squared equals 39 squared. And I'm putting a question mark there because I'm asking if that's true or not. I don't know for sure yet. 15 squared, 225. 36 squared, 1296. 39 squared, 1521. 225 plus 1296 is 1521. And since 1521 does equal 1521, then I know that line segment FG up there, that's what I'm highlighting now in green, is tangent to circle E. Here are a few examples using tangents or finding tangents out of your textbook. Okay, this first one, actually for all three of these problems, 4, 5, and 6, it says, assume that segments that appear to be tangent are tangent. And so on number 4, it looks like MN is tangent to circle L, and so we're going to assume that it is. And what it's actually asking us to find is X, and so what it wants to know is how long would this side ML be. All right, to do this, what we have to remember is that anytime a line is tangent to a circle, that means it intersects the radius at a 90-degree angle. So in other words, angle MNL would be a right angle or a 90-degree angle. That means that triangle MNL, this triangle right here, would have to be a right triangle, which means that I can plug the sides in to a squared plus b squared equals c squared to figure out a missing side length. Before I do that, I have to determine which side is the hypotenuse of the triangle, and in this particular triangle, that the hypotenuse is going to be this one, ML, because it's across from the right angle. So x squared is going to go by itself on one side of the equation. 16 squared and 12 squared go together on the other side of the equation. So I have 16 squared plus 12 squared equals x squared. So let's do 16 squared. It's 256. And I happen to just know that 12 squared is 144. 256 and 144 would be 400. And then if I take the square root of both sides, x would come out to be the square root of 400, which is 20. So the hypotenuse of this triangle, in other words, the line going from M to L, would be 20. It would have to be 20 units long in this one. Number 5 is a little bit different, right? We're using the same idea, the same principle, but we don't have as much information as we had in the last one. We can still solve it though. What am I talking about? Well, it says, again, in the instructions to assume that any line that looks like it's tangent is tangent. So that means we're going to assume here that BC is tangent to circle A, which would mean that that would have to be a right angle, right? The angle between the radius of the circle and the tangent line is 90 degrees, which then means that triangle ABC is a right triangle, which means that we can use the Pythagorean theorem. To do that, though, we would need to know at least two sides of the triangle. The problem is that when it comes to the hypotenuse, I only know part of it. Okay? I know that from D to C, that part right there is 18, but I don't know what AD is. The only thing I know about AD is that it's a radius of circle A, and I know that the radius of circle A is x. So what do I do if I don't know 2 out of 3 sides of the right triangle? Well, here's what I do. Which side is the hypotenuse? It's going to be this one down here. The only thing I can name hypotenuse AC right now is x plus 18, right? If I knew what AD was as a number, I could add it to 18 to figure out how long the whole side was. But since I don't, I'm just going to have to call it x plus 18 for right now. Since that's the hypotenuse, it's going to go by itself on one side of the Pythagorean, the formula for the Pythagorean theorem. So x plus 18 is my hypotenuse. It goes, I'm going to square it by itself on one side of the equation. The other side, I'm going to have 30 squared plus x squared. So think back to last year when you wanted to multiply two polynomials together, because that's really what we're doing here, right? If I have x plus 18 squared, that means x plus 18 times x plus 18. And so I'm going to have to use the thing, sometimes it's referred to as FOIL. It means first, so the first two terms multiplied by each other. So x times x, which is x squared, outside, so the two terms on the outside, x and 18 multiplied together is 18x. Inside, so again we have 18 times x, and then the last two terms, 18 times 18, in other words 18 squared. So 324. So all of that goes on the left side, right? I've just squared x plus 18. One thing I'm going to do before I move all this down is I'm going to combine these two, right? 18x plus 18x is just 36x. So on the left side, I'm going to say I have x squared plus 36x plus 324, and that's going to be equal to the stuff that I have on the right side of the equation. The only thing I can do to simplify here is square 30. So 30 squared is 900, and x squared I can't really do anything with yet. Okay, well, where do I go from here? What I really want, ultimately, is I want to get x by itself. I want to get this x all by itself. So I'm going to strip away everything else from the left side of the equation if I can. What I'm going to do first is I'm going to get rid of this x squared. So if I have an x squared sitting there and I don't want it anymore, I'm just going to subtract it. And if I subtract it from the left side here, I have to subtract it from the right side. And that's gonna be kind of nice because now I don't have any more x squared terms. And if I subtract it from here and subtract it from here, all I'm left with is 36x plus 324 being equal to 900. Still want to get x by itself. Now I'm going to subtract 324 from both sides. Once I do that, I'm going to have 36x equals whatever 900 minus 324 is. And if I'm doing my math right, that's going to be 566. Let's just check to make sure. 576. Good thing I checked. Last step is just divide by 36. So x is going to be equal to whatever 576 divided by 36 is. 16. So x in this triangle right here, or in this image, is 16. So the radius of the circle is 16, and I'm done with that problem. Number 6 is like the ones we did on the last page. Both of those, again, the instructions for all three problems is assume that segments that appear to be tangent actually are tangent. That means that this and this, both of those segments, since they appear to be tangent, I'm supposed to assume that they are, and they both start from the same point right here. So the thing about two tangent lines that start from the same point is that they're congruent. In other words, 5x minus 8 has to be equal to 3x. And now I'm just going to go through and I'm going to solve that equation real quick. I want to get my x terms on the same side, so I don't want any x terms on the right. I'm going to subtract 3x from both sides of the equal sign. Over here, they're just going to go to 0, right? Because I'm not going to have anything over there for now. Over here, I have 5x minus 3x, which is 2x. And I still have the negative 8. I'm going to add 8 to both sides. Again, I'm trying to get this x by itself. Once I do that, I have 2x equals 8. Divide both sides by 2, and x is equal to 4. On this one, I have a circle inscribed inside of a triangle. Right? I have circle W inscribed inside of triangle QRS. What actually ends up happening here is that I have a bunch of tangent lines. Right? So QU is a tangent line to circle W, and QT is also a tangent line to circle W. Since those two tangent lines that I've just highlighted in yellow start from the same point, right, they both start from Q, they're going to be equal to each other. Right? In other words, if this one's 14, this is going to be equal to 14. And it says 2x right now, but I mean, I can basically cross that out and put 14 right here. It wants me to find the value of x, which I could do, but it's almost a waste of time here because I know that this piece of the line, or this line segment QT, has to be 14. So if I wanted to figure out what x was, I would say 2x equals 14, and x would just be 7. But again, for what I'm ultimately trying to do, which is find the perimeter, it's kind of a waste of time to figure out what x is. Anyway, so I know both of these yellow lines are 14 to start with. Then what I can see is over here, I have from T to S, it's not very straight, T to S is 17 inches. That means that S to V also has to be 17 inches. So this part right here also has to be 17 inches. To figure out these two up here, RU and RV, before I even know what they are, I know they're going to be congruent, but I have to figure out what at least one of them is before I can go any further. Here's how I think about it. It tells me that all the way from R to S, or S to R, is 27, and I know 17 of it is taken up by this blue part. So what's left over for RV? Well, 27 minus 17 would be 10. So I know that RV is 10. If RV is 10, then RU is also 10. And now I have every single line segment surrounding circle W. So if I want to find the perimeter of triangle QRS, I'm just going to add all of those up. I'm going to cross them off as I add them to my list. So I have a 14 plus 10 plus 10 plus 17 plus 17 plus 14. So 14 and 14 is 28. 10 and 10 is 20. 17 and 17 is 34. 28 and 20 is 48. 48 and 34 is 82. So the perimeter of this triangle would be 82 units. Last example, we're supposed to find the missing segment giving partial information. In other words, we're not given absolutely everything that we need to figure this one out, but we're given some. The two segments I don't know yet, or that aren't labeled at least at the start, are that one and this one. Those are the two that I don't know right away. Well, this one from Z out to the edge of the circle, that radius, that's going to be pretty easy to figure out because, like I said, it's a radius. And I'm given one of the radii in this circle, and I'm told that it's 6. So that means this one has to be 6. So now I know that the hypotenuse of this triangle, I know both parts, one's 6, one's 4, so the hypotenuse of the triangle is 10. This up here is 10. This down here is 6, and so the only segment I don't have yet is this one out here, XY, which, just to not be confusing, I'll call it Z, because here's point X, here's point Y, here's point Z. Actually, let me call it something else. I'll just call it A. So here's the right angle, right? Because if XY is tangent to the circle, ZY and XY have to meet at a right angle. So which side's the hypotenuse? It's going to be the 10. So 10 squared is going to equal 6 squared plus what I've decided to call A squared. So 10 squared is 100, 6 squared is 36. A squared I don't know yet. Subtract 36 from both sides. 64 is going to be equal to A squared, and I know that the square root of 64 is 8. So A would be 8. In other words, segment XY would have to be 8 units long here.